again a symmetric relation. We need again to convert the negative integers, which are in this case in the y-axis pointing downwards. We need to convert them again to positive values, and that's why we are using again the absolute node. So they are now getting again positive, but they are invisible because they are in the downside of this row. So we are going to shift this part to upwards with the add node, and as you can see, we got this symmetric relation here. And to change the broadness of the negative values, we are adding here a subtract node. And if we look at the result now, we have our reshaped knit pattern. What we need to do next is to make sure that this relationship stays constant, or in other words, that the knit pattern always is in the middle of in these boxes. We kinda can see that this has a relationship that the subtract value needs to be double less than the wrap maximum value. So if we have 0.3 here, we need to have 0.15 here. Then it's in the center. And we can ensure this to be the case in order that we put the same value here and here, but we divide the second noodle with -2. Yes, so it's constant whatever value we change in the maximum of this wrap node. In order, this is the column spacing, right? We can actually rename this node here into column spacing. The same relationship holds also for this wrap node of the y-axis. As we can see now, the same problem appears here also, and it should be the case that this relationship is also proportional to the x-axis, which means that we need to divide the add value also by 2, less than the wrap maximum node of the y-axis. And we can copy this one, put it in both of them. But as you have noticed, that this value is negative here, so we will divide by -2 when we connect this into the circuit. We divide it by -2. So we have actually ensured that the knit pattern stays centered in their respective boxes, while we are changing the column spacing and the row spacing. We can change this to, I actually named that stitch Y spacing in the shader, so we can give it that name. Next, we can also specify the function of these values here. So as we can see, this is actually the width of the stitching. So we can apply here other value, rename it to stitch width. You can put it next to the other ones. And for this one, this will actually be the stitch length, right? So one more here. We have a problem now. If we make the Y spacing small enough and also the stitch length small enough, we see that the sharp edges appear again. This is this actually is programmed like that in Blender. So each row has its space of influence in this case. So we need to adjust that in a other way. So we can increase this again back. So we will just make a copy of this whole thing, of this whole set of nodes, and we will just shift it in between of these spaces. So when we change the Y spacing of both of them, they will connect without these sharp edges. So let's give it a shot. This one you don't need to select because these control actually the same properties. Now we will combine these two with a maximum node. This just combines the maximum values of this and this node. So we can see still just the same image because the other part is not shifted yet. So we need add a vector mapping node. And we shift this to the middle of this. So it's just the half of this one, 0.5. So we again have a relationship of translation of half the value of this Y spacing. In order to map it inside of this one, we need to use this combine X, Y, Z node and connect this to the Y socket here and this one in the location. Oh, this was the wrong one. So, like this. And now when we change the spacing, you can see we actually have a nice smooth connection here. Good. Now we can add the texture to the stitching of the thread. For that we need a wave texture, and input the vector node from this mapping, because this have this rotation which needed to be accounted for in order that this pattern of wave is also following this rotation, right? And we combine this our V-shaped knits with these waves with a color mix node. And put it to multiply. The detail you can set to 0 because it's expensive on the memory. Now it's in the same direction as the knits are pointing, but we will change the rotation individually for these for this texture of the yarn, right? Of the which should actually be the twist of the yarns, which is usually made in a Z or S shape. So we need another vector mapping node. And rotate this separately. And when we move the knits, it moves also with it. We need to make also the same connections for the other side. So you just copy this and make the likewise connections from the other side. And then combine, replace this with the new one. And we can see the result now. So we have now the texture on the threads of the knitting. So this is actually our ply yarn. This is referring to how strong, how much times the threads are twisted together. And we can make now the controllers that will change simultaneously these values here, and the rotation also. Let's make the rotation first. So we need a combine XYZ for the Z socket,